GS911 data logging files are created as comma-separated values spreadsheets. The log file name contains the date on which the file was recorded, a log file serial number, and the name of the controller the data was recorded from. In this example, the log file includes data from the engine controller of a BMW R1250 GS Adventure. To read the log file as a spreadsheet, you need a program capable of reading comma-separated values files. Microsoft Excel is ideal. A good free offline alternative is LibreOffice Calc. A good free online alternative is Google Sheets. If you need to cross-check a number of parameters at once, or read small portions of a log file in high resolution, for example, to check for small anomalies, you may want to read the log file as a graph instead. In this case, watch the reading saved log files as a 2D graph video. With the log file open, you will see the GS911 device firmware version, the GS911 device serial number, the local date and time on which the log file was recorded, the VIN number of the motorcycle from which the log data was recorded, the type and network address of the controller from which the log data was recorded. Column A contains the time intervals in milliseconds at which each value in all other columns was logged. The logging timeline always starts at 0 milliseconds. To be able to use the displayed data effectively, you have to know two important things. First, you need to know which parameters are the correct ones to record under different circumstances. Here, we're investigating the cause of an engine misfire. This example involves possible erratic output from the engine's coolant temperature sensor and one of the engine's exhaust oxygen content sensors. If faulty, both sensors could cause the engine to run abnormally lean or rich. The second thing to know is how to interpret the recorded data. In this example, we know that the engine was started a short time after logging began. Scrolling down the file, we see that the coolant temperature stays low for a while before beginning a slow, steady climb. At no point in the time sequence were there any sudden spikes or dips in the recorded temperature. This indicates that the sensor is functioning normally. At time tag 33,059, the engine was switched off. Coolant temperature stayed steady for a short while, then very slowly began to fall. This behavior is also normal. At the beginning of the time sequence, we see the lambda sensor voltage at 3.35. Progressing down through the time sequence, we see occasional sudden, dramatic dips in voltage. This behavior is consistent with a cold lambda sensor that is starting to warm up. As the lambda sensor begins to come up to normal operating temperature, its measured voltage begins to fall. This is also normal. Scrolling to the bottom of the log file, we see the statistics for this data logging session. This line shows the number of parameters logged, the time period for which they logged, and the average logging interval. This line shows how many times the given parameter was recorded during this logging session. This line shows the minimum value recorded for the parameter during the session. This line shows the maximum value recorded for the parameter during this session. This line shows the average value recorded for the parameter during this session.